Hi, this is Jose Luis here at Parametric Camp, and welcome to another video in this series, Advanced Development in Grasshopper. In this video, I would actually like to go even a little deeper into the C# script component and use this as a way to understand what are actually Grasshopper components. So we know that from a UI standpoint is this box with these connectors, these letters, etc. But if we were only looking at a Grasshopper component from a computer science perspective, from a computer programming perspective, what is a Grasshopper component actually? And how does that integrate with everything that we know from programming in C#, like functions, classes, object-oriented programming, etc.? How are those two things, those two worlds related? So I would like to, in this video, go in a little deeper into how that works and use this as a way to understand what additional functionality and what other possibilities do we have now that we are learning how to write our own C# script components and how we will have even more power as soon as we transition to compiling our own native components and creating Grasshopper plugins. So I'm going to start with an example that we have done here in the series, which is a very simple construct point component, which is a C# script component. And if I double click here, you can see that we have all the stuff that is familiar to us already. We have the run script, and then we have the code that we have written inside. But so far, up to this point in this series, we've kind of forgotten about everything else that was over here. So for this one, I would actually like to go ahead and unfold all these regions that have been hidden all this time. So I'm going to unfold this one, I'm going to unfold members, and I'm going to expand utility functions. I'm going to expand also the using area. And with this, what I would like to bring forth is the fact that a Grasshopper component internally is nothing more or nothing less than actually super conventional C# code. If you look at this, this looks exactly like any other file that we could work with on Visual Studio. It looks like a C# file, C# code file, and the structure is also super similar. We have at the beginning, we have a block where we can import our own libraries. So by default, we use system, we use the Rhino common, and we use the Grasshopper SDK, which I will get to in a few videos. And then also we have here a section where I could myself load some additional libraries if I wanted to, which I will also get to on how to do that in further videos down the road. But what's more interesting here is the fact that this was kind of hidden for us, but run script, this function, the main function that gets executed every time we run a component, a Grasshopper component, and the one where we have written our code, is nothing more and nothing less than a function, a very particular function that lives inside of a larger class that is called script instance. And this class is very interesting because it inherits from this Grasshopper script instance superclass, which means that it takes a lot of functionality and it takes a lot of the logic from its parent. And additionally, we can see that because it's a class, it has a particular function that Grasshopper probably knows how to execute, and probably Grasshopper knows how to take data that is coming from an input and turning that into an argument that gets passed into the function, etc., etc. And Grasshopper also knows how to take the output that we generate and we reference and then place that in the wire that flows out of the component. So all of that is probably handled by Grasshopper. But what's interesting is that we actually have access to a lot of other functionality that comes from the fact that this component is just an instance, it's an object in itself that has been instanced and is a child of a larger class that is the base. And because we are inheriting from a base, we will have all that additional functionality. So, for example, what does that mean? Well, when I was saying before that we could use the print function to just print some value to the console, for example, hello world, right? and if I execute this, you can see that from the output, I'm getting that message here. What this is, this function is not just a function that lives in ether or in limbo. This function is a function that is available because here it's part of the implementation that comes with script instances. And as you can see, we can see that this function, there are two versions of this function. The one that takes one string of text and the other one that takes a string of text and a series of arguments afterwards that we can use for formatting the string. So for example, I can say here, hello world, and then here I can type world, and then I believe, well, let's say Jose Luis to change. And if I execute this, you can see that this gets changed. So if you don't understand this, actually, I have another video on my Learning C# playlist where I talk about string interpolation. So there should be a link on the description or popping up with a card somewhere here. So make sure to go check it out so that you can understand this better. All right. But this is also the reason why, for example, we cannot just print a number, right? So if I hit execute this, you can see that script instance, the class that we're living in, dot print doesn't have any overload. This takes a pure integer as an argument. All right, it's just not part of the implementation. So are things now starting to, is the puzzle starting to fit together? Are the pieces starting to fit together? So for example, we have this other method that we have not seen in these videos, which is reflect. And reflect basically prints useful information about an instance of an object to the out parameter. So for example, here I have a point that I have created as an instance. So if I say reflect, if I say print p, then I'm going to get an error because I cannot print a point object, but I could convert this to a string, right? And then if I did that, then I will get some string representation of that point. However, if instead of that, what I use is reflect, what I will see is that through the output, I will print out a reflected version of all the properties and all the methods that the point3D structure has. So you can see that we can do multiply, that we can find the coordinates x, y, z, that we can have the distance to, etc. So we have a lot of functionality that we can analyze using the reflect method. Okay. And you can also see that you can have a special version for a method name. So for example, if I want to say subtract, then I will get additional information. And then the information that I see is what are the references, what is it that this method takes, what are the overloads. So for example, I can subtract a vector and a point, and it returns a point, and I can subtract a point and another point, and it returns a vector in return. All right. Actually, I believe this reading here that you see is actually Visual Basic, which I don't know why it's printing this out in Visual Basic, but that's what it is. All right. But these were methods, these were functions that live inside of this script instance, which is inside of this class, which is exactly what a Grasshopper component is. But if we go to members, this is where actually the real power is, in my personal opinion. Because, for example, you can see that here we have, for example, we have a private integer that tells us how many times this component has executed, which is kind of cool. So, for example, if I say print this component has run, and then this dot iteration, because remember we are in a class, so I can use the this dot to refer to a member that lives inside of this on this class, and then I can close this and execute this, and it says this component has run 0 times. It has run 0 times because I just changed the code, so everything got reset. But for example, if I now hit OK, and then if I start moving this, you can see that, well, I am actually not sure why this is not working. I believe that this should work, but maybe there's something going on. But anyway, it doesn't really matter because actually I would like to explain to you how to implement this manually yourselves. So don't worry, we're gonna get back to this in a second in the future. But for example, one of the super interesting things is that we have access to three references that point to the document in Rhino that we're working with, the document in Grasshopper, so the whole definition that we're working with, and this particular instance of this component. And what that allows us to do is, because we have access to places where we can query and we can ping the component, we can ping the Grasshopper document and the Rhino document. There's a lot of stuff that we can do actually, and there's where these are actually the three MVPs, the most valuable players, if you will, of the Grasshopper component development, in my opinion. So, for example, what we can see is that if I type component and I type dot, what you can see is I start getting access to a lot of stuff that is part of how Grasshopper components work. All right, and there are many properties, methods. You can subscribe to events, and actually this can get pretty hacky. And I will explain in the next video where to take a look at documentation and how to learn about this. But for example, one thing that I think is super interesting, one function that I think is super interesting is called the add runtime message. What does that mean? From this component, I can call the add runtime message method. And what I can do is I can use this method to pop up one of those tiny balloons that are clear, orange, or red, and that I can use to express error messages or warnings. So for example, let's say that I wanted this message to this component to display a normal balloon, like, and so a normal balloon with some kind of hello message. So what I can do is I can call the runtime message method, and then I can choose first which type of message I want to display, and the type is chosen by using the Grasshopper runtime message level enumerator, and then I can press dot, and I have four options: just blank, error, remark, or warning. So for example, let's say I want to do a remark, all right? And then the message is going to be hello pcamp, all right? And then what I can do is if I execute this, you can see that I have this tiny bubble now on top of the component. And if I click, you can say, hey, hello pcamp. So I've created a tiny bubble that it's right over there. So for example, something that I could do is I could say if the point, the x coordinate equals 0, or no, it's less than 0, and p dot y is less than 0, and p dot c is also less than 0, something that I could do, this is terrible, but for example, I could say add component, add component, blah blah blah, and then the runtime message, and I could say warning, and I could say your point is on the negative octant, if in case that was something to be worried about, which I don't know why it should be, right? But you see now, for example, I can move this all the way to negative. Oh my god, then I'm gonna have to change this because of course. And now we can move this to negative and negative and negative, and you can see that the component now turns orange, and it gives me this message: your point is on the negative octant. All right? Or I could instead, for example, if I needed to, I could turn that into an error, right? And then I can just execute this, and now this gives me an error, all right? The component doesn't stop working, so it still generates the point, but it goes red, and it flags this kind of like error, like your point is negative, whatever, blah, blah, blah. I don't know why. But this is a really good way in the world of Grasshopper of signaling problems and letting people know that something is not going well, all right? So, for example, let's see a couple of real world examples that I would like to show you before we move on to the next video about doing error handling. So for example, if we go back to the plugin that we've been developing throughout this series, if we go to the vector components, if you remember the tween vector the tween vector component that we made, this was a component that we could use to tween two vectors from one to the other. And actually, let me add some visualization here so that we can see it better, okay? Okay, here you go. So I have the two vectors, the one on the first one and the second one, and have the tween vector, and we know that whenever the parameter approximates 0, then the vector is equal to the first one, and when the parameter gets to 1, then the tween vector is equal to the second one. But tweening is typically an operation that is performed proportionally from 0 to 1, like the normalized range between two extremes, right? However, mathematically, it doesn't have to be the case. It can go from anywhere negative to anywhere positive. It doesn't really matter. However, because it's not a very intuitive concept when we go beyond the 0 to 1 range. So maybe we want to add here a warning where it say, hey, just so you know, your tweening parameter is outside the 0 to 1 range. Just in case. It's fine. We can take care of that. We can deal with that. But it may not be what you want to do. Just letting you know. So we can do that by going here and then say on the algorithm, we can just add here a warning just in case. And then we can say here, for example, if the parameter t that we're tweening from is less than 0, or the parameter t that we're using for tweening is greater than 1, then maybe there's something that the user didn't really do correctly. Or maybe they do, we just want to warn them. So remember, in the component, we have access to the component object, which is a reference to the parent that is owning this one script. So think of this as the component being the whole thing, the UI, the buttons, the buttons, the wires, the right click, this menu, that's the component. And then the script, which is what we are working with, the script instance, is the code, just the code part that is running inside. All right. So, oops, what did I do? Oh, I didn't save that. Okay. So add a warning here. I think I closed this without. So if t is less than 0 or t is greater than 1, then add a message, which is going to be component dot, and then we're going to add a runtime message, and then Grasshopper runtime message level. This is an enumerator, so we're going to use here warning, and we're going to say your parameter is outside the 0, 1 range. Okay, and we're going to close parenthesis, and we're going to accept the changes. If you see now, as soon as I go beyond 1, the component goes warning. It's fine, it still works perfectly. But as soon as we also go below 0, the component also goes into warning mode. So I think this is actually kind of nice. It's a very nice way of adding helpful notes in development for users, just to make them aware of things. Let's see another example. So for example, another example that of something that should display an error is when we operate with vectors and we want to unitize them. Because if you remember, for the most part, we can always unitize vectors, except that if you remember, the operation of unitizing vectors requires dividing by the length of a vector. And if the length is 0, then we can't really unitize that vector. So you can see that if the vector is a 0, 0, 0 vector, that is the length is 0, then we don't have the possibility of unitizing that vector, because it doesn't really have a direction, right? So in this case, this component should probably display an error, even though it still spits out a vector that is the same, right? So something that we could do here is, for example, we could say if v.length if the length of, no, wait, sorry, v dot, and then where is the length of this? If v dot length equals 0, then what we could do is we could say component add runtime message and then grasshopper runtime message level dot error, and we can say cannot unitize a 0 length vector, for example. And then we can execute this, and we can say that, see that now at this point we're getting an error when this is the case, and at this, if we move any of these, we're not getting the error anymore. And then we'll go back to 0, we get the error. Now, one thing that is interesting is that we can improve this code a little bit, because if we remember the v.unitize method, can you see how it returns a Boolean? All right. This is actually super useful because that Boolean is telling us whether if the method was able to successfully unitize the vector or not. So what this means is that what we can do is that we can make a bit of a shorthand and say, I'm going to place this here. All right. And if the result of this equals false, it means that v could not be unitized, and therefore something went wrong. Cannot unitize this vector. Okay, and then I'm going to hit OK, and then we have the exact same problem, and now it's working well, and now it's working well, and now it's going to go back to not being able to work well. All right? Beautiful. Okay, so this was learning how to control, learning and understanding what a Grasshopper component is, what is the hierarchy between Grasshopper components and instances of script components. So we can see how all of this is actually just classes, and all the things that we can access are either methods or are either properties that belong to this class. All right, and then because of that, we can access, for example, the component property, which gives us access to a lot of functionality from the parent object, from the component. Or we could also access the properties from the Grasshopper document, from the driver document, like for example, where is this file saved on your system, how many components are available in this definition. You can actually mess with the other components. And if you are familiar with the meta hopper, do I still have it here? I don't know what it is, but I used to have it somewhere. If you're familiar with the meta hopper component plugin by Andrew Human, he actually uses a lot of that, a lot of those techniques to mess things around and to play with the Grasshopper definition itself. Okay. All right. Good. That was great. Thank you for that. And I think what we're going to do is I'm going to record another video where we're going to do a few more hands-on examples on error handling, and we're going to keep working on our plugin, and to certain components we're going to add error messages and warning messages whenever things don't work correctly. Okay, so that's going to be the next video, but in the meantime, if you like this video, maybe hit the thumbs up button, maybe subscribe to the channel, or maybe just say a few words of gratitude, tell your friends, I don't know. Whatever you think it works best for you. Okay? Thank you very much, and see you on the next video.